This call is now being recorded.
Good evening, everyone. Welcome to class 5th of Aksharamaala. I'll be teaching physics again. So, today's topic will be electricity. This is chapter 12 of your textbook, class 10th. It is as per the request of the students. They had some doubts in this chapter, so they asked me to teach this chapter from beginning. So, let's continue with it. So, first question is, what is electricity itself? I'll write slowly also, as decided I'm covering it very quickly. So I'll write it neatly and slowly also. Electricity is a controllable and convenient form of energy for a variety of uses in homes, schools, etc. Like hospitals, factories, wherever you see there's use of electricity and so on. So this is just a book definition from NCRT itself. It is a controllable and convenient form of energy. Controllable means that we can control its flow, its amount, how much we want it, and convenient means that it makes life easy for us. So this is a such form of energy which is controllable and convenient, and we use it for variety of purposes. Like in homes, you have fans, like any electric device, your mobile phone, you charge it using electricity, or say refrigerator that also works on electricity. Many devices are there. In schools also fan again, maybe projector, microphones in the assembly, loudspeakers, any other electrical device. In hospitals, most of the machines are running on electricity also. So in this chapter, the uh, aim would be to question some answers, attempt to answer the following questions. First is, what constitutes electricity? Constitutes means that what is electricity made up of? What, what is electricity in physical sense? Second is, how does it flow in an electric circuit? Another question is that, what are the factors that control or regulate the current? And basically, it's the electric current, not any general current. through an electric circuit. And one more is that we'll also see or look into the heating effect of electric current and its applications. So, starting with electric circuit and current. So, what is current? First of all, the electric current. How would we define it? Before that, let me give some analogy. Like uh, when water flows, we say there is a water current in the oceans. When the water flows in a certain direction or pattern, we say that there is a water current. When air flows from one way to another, we say there is an air current. Current basically defines, or you can say describes, the flow of some quantity or something. Like air current describes the flow of air, water current describes the flow of water itself. Similarly, by this analogy, we say that electric charge flowing through a conductor is described as the electric current in a conductor. So, what is electric current? It is the flow of electric charge. This some quantity which we were talking about whose flow is electric charge in this case when you define electric current. And a proper definition of electric current would be amount of charge flowing through a particular area per unit time. Now, what does it mean is, suppose this is some cross sectional area and some charges are flowing in this direction. So the number of charges that pass through this area in 1 second, suppose they constitute a total charge of Q, and in 1 second this much charge passes through this area. So the current here will be equal to Q divided by 1 second, that is charge per unit 1 second, so it will be Q itself. Or in other words, you can also say that electric current is rate of flow of electric charges. So there is some history to the conventions used for the electric current. The electrons, that is the negatively electric charged particles, they were not discovered. They were not discovered before the discovery of electricity itself. So, current was considered as just a flow of positively charged particles, or you can say positive charges. And the direction of current, it was given by the direction of these positive charges, direction of flow of the positive charges. This was before the discovery of electron. But now we know that by convention, direction of the electric current, direction of electric current is equivalent to the direction opposite to the direction of the flow of electrons, the negative charges. Suppose this is a conductor, and in this, electrons are flowing in this direction from left to right. Then by convention, we say that in this conductor, the electric charge is from left to right. This will be the direction of current. That is opposite to the direction of electrons. And the symbol of current is I. We denote electric current by I. Its SI unit is ampere, and the charge, the for the charge, the symbol is Q. Q or small q also you can use. And SI unit for charge is coulomb, or its symbol is basically C. So this current being denoted by ampere, how would we define 1 ampere flow of current? 1 ampere is defined as the flow of 1 coulomb charge per second. We can see it from here also. This one, where we define this. Current is the rate of flow of electric charges. It is charge flowing through a particular area per unit time. So for 1 ampere, we have 1 coulomb of charge passing through a particular area of cross section, and in given time 1 second. So we can also write it as 1 coulomb second inverse. This much is 1 ampere. And small quantities of electric current can be measured in smaller units, which are milliampere and microampere. Excuse me. This is milliampere, and this one is, the symbol is for micro, that is mu symbol, microampere. Milliampere is basically 10 to power minus 3 of ampere. It is 1 by a thousandth of ampere, and microampere is 10 to power minus 6 amperes. It is 1 by 1 millionth of a part of an ampere. And the instrument which is used to measure electric current, the instrument which we use in laboratories to measure the electric current in magnitude is called ammeter. And its symbol in electric circuits is like this circle in which A is written and its terminals. This ammeter is always connected in series in a circuit through which the current is to be measured. Now, what does it mean is that suppose we have an electric circuit, there is a battery. This is the positive terminal of the battery, this is a negative terminal. Say there's a switch and an electric bulb. If we close this switch, then electric current will flow in this circuit and it will make the bulb glow. The electric bulb will glow. Now, if we want to measure the electric current in this circuit, like how much is the current, then this device called ammeter is used to measure it. And how do we install it? It is connected in series in the circuit. In series, it means that along the flow of the current itself. So here is this circuit. This is the battery. Again, here is the switch. And it will be connected in series, that is along the wire, so you can say, or along the current itself. Like this, the positive face is the positive of the battery, negative face is the negative of the battery. If you connect it in the opposite direction, then it will give negative current value. So negative basically describes the direction depending upon the terminals you will connect. And this ammeter, it will give you the reading. There are like analog ammeters also, in which there is a needle and there are readings like 0, say 10 on this side and 10 on this side. So if you apply here and suppose the current is 5 ampere in the circuit, just for an example, usually the current is small, around 5 milliamps or say 50 microamps or 500 microamps. So the needle will point in this direction after deflection. If you connected it in the opposite direction, suppose this is plus and minus terminal. If you connect it like this only, then it will give the positive reading. If you flip the terminals by mistake, then it will give deflection in the opposite side. So that is ammeter. And just as I told that positive terminal of cell through the electric devices, this faces to the positive terminal of ampere, and similarly negative terminal of battery through electric devices faces the negative terminal of uh, ammeter. Like here in the diagram also, this positive terminal of battery through this electric device, that is called electric bulb, it faces the positive terminal of ammeter, and negative terminal of electric battery, it faces the negative terminal of ammeter. This is the convention to connect it. Let's do a numerical. It is an NCRT question only. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So we are given that the current flowing through the circuit is 0.5 milliampere, and this could be measured using an ammeter drawn by a filament of an electric bulb. Here the electric bulb is the device which draws the current and generates uh, light. You can say it draws power from this particular battery and draws this much current, and for a time duration of 10 minutes. All right. So we have to convert this 10 minutes into SI units also, because our current is in SI unit. So how will we do it? The formula is that current is charge per unit time. So this implies that charge is current into time. So charge is here 0.5 amps. Time is 10 minutes. So 10 minutes and 1 minute is equal to 60 seconds. So 10 minutes is equal to 10 into 60. That is 600 seconds. So the charge becomes 0.5 into 10, that is 5, and 5 into 60 is 300, and the SI unit is coulomb. So this is the answer. Example 1 done. Let's pick up some other questions also. First question is, what does an electric circuit means? So here we were using the term electric circuit to describe this system. So what will an electric circuit be? Vijay. Vijay, can you hear me? If you are there, you can like open your mic. Let me see the host controls. Yeah. Okay, so electric circuit is a, you can say, a system or a combination of electric devices, one power supply, that will be say battery, and in earlier example the electric device was electric bulb, and we also need connectors, or you can say connecting wires. These are conducting metallic wires, usually made of copper, because copper is a good conductor of electricity. So if we combine all these things together, then the system which is produced is known as electric circuit. Second question is define the unit of current. It is ampere. We already defined it. The 1 ampere is the, oh, hello, hello. Yeah, it's working. I was just checking the mic. So 1 ampere is already
Hello,
defined. Yes, Vijay.
sir. Good evening.
Good evening. Good evening. Flow of. You have any doubt? Like today, I'm using electricity as you asked.
Yes, sir.
So if you have any doubt in the middle, just stop me. Okay, anywhere you want to.
Okay, sir.
Okay. So 1 ampere is
Sir,
defined
in
as the
our
flow of. Hmm. Yeah. Say.
class, one member only, three members only, sir.
Yeah. There is you like you Vijay. Then there is Karthik, and there is one more student. What is this?
Okay, sir.
Aksharadan.
Okay, sir.
Okay. 1 ampere is defined as the flow of 1 coulomb charge per unit time, or you can say per 1 second. So this is how we define ampere, the unit of current. Third question is calculate the number of electrons constituting 1 coulomb of charge. So we are given with in third question, the charge is equal to 1 coulomb, and they have asked the number of electrons constituting this much charge. So it's simple, we can use a simple formula that charge is equal to number of electrons into charge on one electron, because charge is made up of the negative charges, the number of electrons flowing. So if we are asked the number of electrons in 1 coulomb, simply we can multiply charge on one electron into number of electrons flowing, and that will give us the total charge. So here we are given with that charge is 1 coulomb, and we know charge on one electron is 1.6 into 10 to power minus 19. coulomb. So coulomb cancel. So Ne will become 1 by this E goes here, minus 19. It will go above and become 10 to power 19, 1.6. You can write it as 10 to 10 to power 18. This is 6.25. So number of electrons comprising of 1 coulomb of charge is 6.25, 10 to power 18 electrons. It has no units as it is a number. This is the answer. Moving on. Next topic is electric potential and potential difference. So the question arises that the current is defined as the charge of flow, but what makes the electric charge to flow? So here also we can take the analogy of different phenomena. So in nature, suppose some x quantity, it will always flow from higher potential to lower potential. Now, what does it mean to flow from higher to lower potential? Suppose there is an object, say a tennis ball. So it will always fall from higher height to a lower height by itself, unless and until we throw it ourselves from lower to higher height. If you like put it in air with your hand and you release the ball from your hand, it will fall towards the ground because of gravity. So here height is the potential. There was a variation between one point and another point, that is ground. There was a difference between these 2 points of something which is called height potential, or simply the potential energy, the gravitational potential energy. So due to the difference in height, the object flowed from higher potential to lower potential. Similarly, suppose if x is a fluid, then it will one second. Just bear with me, I got disconnected for some reason. Suppose x is a fluid, then the fluid follows from high pressure region towards low pressure region. Like for an example, fluid, you can think of air or water. Water always follow from high pressure region to low pressure region. Air also, if it's a hot day, then heat, the heat will make the air light and it will travel upwards, and there will be a low pressure region. So wind will flow from, or the air will try to rush into this region from the surroundings. That's why it creates wind also. So from high pressure region to low pressure region, this is the direction of a fluid here, the case of air and water. So everything in nature, it follows from high potential region to a low potential region, and the potential varies for different objects. Like for a mass object like a ball, the potential is the gravitational potential energy, that is height itself. And for fluid, it's the pressure potential. Similarly, we can say that electric charges, that is electrons, they flow because there is a difference in some potential, or you can say there is a difference of electric pressure. Like water flows due to the mechanical pressure because there is a difference in mechanical pressure. We can similarly say the electrons flow due to the difference in electric pressure across the terminals of a conductor. Conductor means something that conducts electricity, like a metallic wire. And this difference in electric pressure, this potential is defined as, or it is called as, electric potential difference. Electric potential difference along the conductor, or you can say across the conductor. And this electric potential difference, it is produced by batteries, which make the electrons flow from one point to another. Battery is basically one or more electric cell combined in series usually, and the chemical action within a cell generates the potential difference across the terminals of the cell. There is some chemical reaction inside the cell that generates the potential difference across the terminals of cell, and this potential difference is the electric potential difference, which makes the charges flow from one point to another point inside a conductor. And this potential difference is created even when there is no current drawn from battery. And in order to maintain this electric current, in a given circuit, the electric cell has to expend its chemical energy stored in it. So basically, when we are trying to make the current flow, or the make the electric charges flow so that current can be produced, it has to be taken care of because of some energy, because we cannot create energy just like from thin air. So it's basically the energy coming from chemical reactions which produce electric currents on a deeper scale. So chemical energy is being converted into electrical energy. What will be the definition of electrical potential difference? Electric potential difference in an electric circuit, you can say, carrying some current is defined as the work done to move a unit charge from one point to the other. Now, what does it mean is that suppose this is the conducting wire and this is point A and this is point B. If we take a amount of 1 coulomb charge here, so we have to move this charge from point A to point B, and we need to give some energy to the system. Some work has to be done, otherwise it will not move. And that work is done by some battery which we apply. Suppose we apply it here. So this potential difference produced by the battery, it will be 1 volt when there is a 1 coulomb of charge there, and we do a work of 1 joule to move it from there to here, from point A to point B. So if we have, say, some potential difference, then it will be equal to the work done in moving the 1 coulomb charge. Potential difference between 2 points is equal to work done in moving the charge from point A to point B upon the charge itself. That is per unit charge, or you can say 1 coulomb of charge. And SI unit of potential difference is volt, or the symbol is V. So by this we can define the 1 volt potential difference as 1 joule when 1 joule of work is done to move 1 coulomb of charge in carrying the current. So this much potential difference is termed as 1 volt. And this potential difference across 2 points is measured by an instrument called voltmeter. And its symbol is circle V, 2 terminals plus minus. And this voltmeter, it is connected in parallel across the points between which potential difference is to be measured. Suppose this is a conductor. You can say there is some electrical component here, say a bulb, and we apply a battery. So current will flow through this, and some potential drop will happen across this, say, 2 terminals. So there are 2 bulbs. We want to measure the potential difference across this one. So the way to connect a voltmeter is in parallel across these 2 points. Ammeter was connected in series, but voltmeter, it connects in the parallel. So this will give the amount of reading that the much potential difference is dropped across it. Let's do question. Question is how much work is done in moving a charge of 2 coulomb across 2 points having potential difference 12 volt. So we are given with the amount of charge being moved across 2 points and the potential difference across those oh, potential difference across those 2 points is 12 volt. So how much work is done? We know that potential difference is defined as the work done per unit charge. So this implies work is, we take Q to this side, potential into charge. So work will be, potential is 12 volt and charge is 2 coulomb. So 12 into 24, it's 12 into 2, it's 24 volt coulomb, or we can say 24 joule. Let's do some more problems or questions. First question is name a device that helps to maintain a potential difference across the conductor. So the answer is battery or a cell. Second question is what is meant by saying that potential difference between 2 points is 1 volt. So suppose the 2 points which we just discussed, points A and B, if the potential across these 2 points is 1 volt, then it means is that it will require 1 joule of work to move 1 coulomb of charge from here to from A point to B point. How much energy is given to each coulomb of charge passing through a 6 volt battery? So work done is charge into potential. How much energy or work done is given to each coulomb? That is, charge is 1 coulomb and potential is 6 volt. So it is given, it gives 6 joule of energy to each coulomb to make it pass through, to make it move from one point to another. Now the next topic is circuit diagram. It is convenient to draw schematic diagrams instead of a exact picture. Like suppose we are using an electric bulb, so to draw an electric bulb will be tedious every time, or some another electric component. So it is convenient to draw schematic diagrams. In this, different components of circuit, these are represented by the symbols conveniently used. So what does it mean is that we use some schematic diagrams, that is we use symbols instead of the actual picture of the electrical components. Like here we have been using this symbol for electric bulb. This is not the picture of exact bulb, but this is the symbol for it. Similarly, this symbol here, it is a symbol of battery. in which this two parallel bar single symbol is the symbol of a cell, and this whole two cells is a symbol of a battery. This is a symbol of voltmeter. Similarly, there are other symbols for some usually used electrical components. Some conventional symbol for some of the most used electric components is listed below. This is a list of some most commonly used components. The electric cell, it is made by two parallel lines. One line is longer than the other. The longer line is the positive terminal of cell and this negative, and these two are the connections to the cell. And battery is basically the combination of cells. You can put any number of cells. This will also represent a battery, the combination of two cells. And positive terminal will be the terminal on the end of the this whole system of the cells. Negative on the other side. And this is the plug key symbol. This is the open, and this is when you put a dot in the center, it's a closed plug key symbol. A wire joint. Suppose there are many number of wires passing through us in a circuit, so it will become tedious. So to show where the wire is connected, so the symbol for it is you can just make a dot over the overlapping of two wires, and it will tell the wires are connected here. And if we don't want to connect the wires, then you can simply just draw like this, or at this level you can make a hook around this wire that it's uh, going over it, not it is not joined there. Symbol of electric bulb is this one, which we discussed earlier, and this one is tedious to make. You have to make this like glass, then the bottom one, then a filament. Or simple way you can just make this. This is a symbol of resistor, which we used in the first class also when we were discussing how the regulator in a fan works. Or the symbol for resistor is this physical, and the symbol of the physical quantity resistance is R. This is a variable resistance symbol, or it is also called rheostat. Just make a resistor and put an arrow through it, or this one, either way. If we slide this arrow on the top of a resistor, then it will change the resistance. That's the meaning of this symbol. This we discuss the symbol of ammeter. This is the symbol of voltmeter. Ammeter is connected in series in the circuit, and it is connected parallel across the points where we want to measure the potential difference. Let's quickly summarize. So we studied electric current. Electric current is basically the flow of charge from a particular area per unit time. What else? Units of current, that is ampere. Units of charge, that is coulomb. and time we know it is second. So 1 ampere is defined as 1 coulomb charge per unit time. And then we did some questions on numericals. Second thing we studied is electric potential and potential difference. Electric potential is the potential which makes the charges flow. Like the pressure potential is what makes water or fluid flow. So electric potential is the potential which makes electric charges flow from one point to another in a conductor. And potential difference is the difference between the electric potential at 2 points. Third thing we studied is the circuit diagrams. Or you can say the schematic diagrams. There is these symbols which we use instead of the actual picture of a electrical component to show in an electric circuit. And electric circuit is basically a combination of a power supply, that is battery, some electrical components, a resistor, a bulb, and you can put in a plug-in key also, or maybe a mechanical switch. If we flip it down, then the current will flow through this system, which is the system is called electric circuit. Current can be measured by putting an ammeter in series, and potential across terminals of an electric component can be measured using a voltmeter. This is all for today, and if you have any doubts, you can post it on Aksharamaala portal, which I usually say. I'll repeat it again. I've also put the assignment. You can do it because the deadline is on 2nd or 3rd of Jan. You can check it on the portal itself. And if you are not able to access the portal also, you can put in the WhatsApp group which we have formed. And thanks for watching. That's all for today.